In the past few videos, we've talked a lot about instance variables and instance methods. Remember that we said instance attributes, and by that I mean instance variables or methods, they belong to a specific instance of the class. Okay? An instance, as we've sort of described, is something like, point p2 equals new point. So p2 is an object or an instance of the point class. Okay? So each copy, or excuse me, each instance of the point class will have its own copy of, for example, the x and the y instance variables. Okay? And then whenever there's an instance method, for example, distance, we can call any instance method on any particular instance of the class. For example, p or p2 or any other point that we've created. Okay? But there are also static methods, and we've talked about these before. A static method is a method that belongs to the class itself. Let me rephrase that. A static method is a method that belongs to the class itself and not a particular instance of the class. Okay? So, what do I mean when I say that? Let's consider a method that generates, well, I'll do this in IntelliJ just for clarity. So consider the following method. Let's say we have a method called generate random point. Okay, and we'll just say that this method generates a random point whose x, y coordinates are between 0 and 42 inclusive. Okay? So, ignoring what this does for just a moment, let's consider the following code. So, I want you to ask yourself if this makes sense. p.getRandomPoint. So, this compiles, okay? And it it works. But does it really make sense to call this type of method on an instance of the point class? In my opinion, no, it doesn't, because generating a random point really has nothing to do with p in and of itself. Rather, it's more of something that the class itself can do, and not a particular instance of the class. Okay? So, until now, every method that we've written, excluding test methods like JUnit test methods, and the compare method from the comparators, everything has been static. And what that means is it is a method that operates over the class itself and not an arbitrary instance thereof. Okay? So what we can do is label this method as static, and we call that by doing point.generateRandomPoint. Now it's important to realize that you can still call a static method on an instance of the class. That's perfectly valid to do, but it's considered bad practice. Okay? So whenever you have a static method, you should always call it on the class itself and not an instance of the class. And even IntelliJ will tell you this. It'll say, hey, what you're doing is, bad practice, effectively, so you should call it with the class name and not an instance of the class. Okay? But I'll leave it like this just to show you that, yes, it can compile, and it works just fine. So, how will we write this method? Well, I mean, at this point, it's just like writing any other arbitrary method. So we can do return new point, because we're going to generate a new point, and then its x and y coordinates are just going to involve the random generation of a number between 0 and 42. And of course, we've seen how to do this before with the int stream example. So we can just generate a number between 0 and 43 exclusive, and then just cast that down to an integer. Okay? Very good. So now if we run it, and we can print out the x and y coordinates of, let's just say, P2 and P3, just to see what they both get, because they'll both be distinct points. So the first one is 1, 2, the second one's 16, 27. Okay, 4, 10, 16, 4, 34, 13, 29, so on and so forth. Okay, so that's pretty cool. We could write, excuse me, we could write another method, for example, static, let's see, how do I want to do this? Double average distance to origin. So let's say we want to write a method called average distance to origin, and we give it a list of points. Let's say we want to compute the average distance of all of these points to the origin. Okay, so again, it doesn't really make sense to call this on, let's say, an arbitrary point. Like we could do p dot distance to origin. So let's just make this return 0 for now. We could do like list dot of p, p2, p3. Average. What did I call it? Average distance to origin. Yeah. So we could do this, but again, it would have the same issue of that. Like, this is bad practice. You shouldn't call static methods on instances of the class. So we'll change this to point. And yeah, so how can we do this? Well, let's use the stream API. Let's say, so you could use a for loop and then compute the distance from each point to the origin, take the average, but let's do this. So let's say, let's also assume, just for the sake of the example, that this list is not empty. We can do dot stream, dot, let's see, dot map, and then we'll do, let's see, so this is a list of points, so we're going to give it a p, and then we're going to map it to its distance to the origin, and then we're going to, so there's a function called map to double, and what this does, in effect, is it converts this stream of double objects into double primitives, and from there, we can actually use the dot average method, okay? And then because we assume that there is at least one double, or there's at least one point in the stream, then this value will exist. Remember that it returns an optional double. So we can just convert it into a double by doing get as double. Now you have to be careful that if your list can be empty, then this can potentially fail because get as double could potentially fail. Okay? So let's print out this value. So according to this, the average distance from, so this is actually kind of interesting. So we're computing the distance from the origin itself. So let's take out p. Let's okay. So here with these 2 points, we're saying that the average distance from these points to the origin, so the average distance between these 2 points is this value. Okay? So that's why, well, that's why it's a bad way to start that sentence, but this is the utility of static methods. They are methods that you can call on an object, on a class, rather than a particular object, and usually they're about doing things like, they don't act on a particular instance, right? And in particular, one thing you can't do in a static method is access instance variables, because note that there is no implicit parameter. So when you're doing this like .x, this doesn't work. So like, we can't do something like this because there's no implicit parameter when you're calling a static method. So there's no way for there to be a this at all. Okay? So you can never use this dot, or you can never even do like int z equals x. You can't do x because this is a non-static field and it's inside of a static context. Okay? So you can't access instance variables inside of a static method.